Okay, hi and welcome to our notes on 3.5 compound inequalities. We're going to focus on what they are, but before we do that, let's get a couple things down here, a couple of terms that maybe we should talk about. One, greater than, just to recall from our previous notes, if you run into, as you're reading it, right, from left to right, if you run into the large open side of it, that is a greater than sign. If you run into the little point, that's a less than sign, just to kind of review so we have the same terminology. All right, now that we have that, let's take a look here at what it means to have a compound inequality. So let's look at this inequality. So we've got x is greater than or equal to -5. Remember the x, we kind of say sometimes out loud, is the solutions, right? The sign here is a greater than sign, and our boundary, or the point that kind of defines where our solutions are at, are -5. So if we went to graph that, we would go to -5. We would say the solutions are greater than, so we would graph to the right. And you can see that here by this red line. These are two separate inequalities that we're going to eventually graph together. The second inequality that we're looking at is x is less than or equal to 7. So again, our boundary point is 7. The value is less than, or our solutions are less than that, so we graph to the left. Those are two separate inequalities, but we can combine them under one equality and call them a compound inequality. Let me switch my pen here. I'm in the wrong color. We can call them a compound inequality, and that just means that it has an upper boundary and a lower boundary, meaning that we're going to take these two single inequalities here and we're going to put them together, one with a lower boundary and an upper boundary. It's kind of like having two restrictions instead of just one to pay attention to. So if you look here really closely and we chop off the green one here, because that's now got a lower boundary of -5 because we're combining the two, right? -5 is our low boundary and 7 is our high boundary. We're going to go ahead and do that here. So we chop off the top end of 5. What we end up with is a segment that runs from -5 to 7. That's what a compound inequality is. It has a lower boundary that we have to pay attention to and an upper boundary, and we can write them together. We put the value of x in the middle, or our solutions, right? All the possible values that could make this inequality true, and they're going to range and include, in this scenario, both -5 as the low boundary and +7 as the high boundary, or the upper boundary. So here's the official definition for compound inequality. We get two main types. We get an and compound inequality, and we get an or compound inequality. And compound inequalities look like the one we just did here, right? They're going to look like a solid bar. The solutions are included in between, so all the values are between our boundaries. And if we get an or, and I'll explain a little bit more what that is when we get there, an or then is kind of an exclusionary sense. It says all the solutions are all the values away from these two boundaries. They do not overlap. They do not share anything in common. So and has stuff in common, or does not, but that kind of makes sense with the words. So how do you read a compound inequality? Well, here's the one from before. -5 is less than or equal to x, which is less than or equal to 7. You can see that that's what I said here, so I read it the correct way. Or you can say x is between -5 and 7, and then you can say inclusive or exclusive, depending if it's included or not included. And again, remember, included means darkened circles, excluded means open circles. All right, so now that we have that, let's practice writing some of these. So let's get down to this example B here. It's an actual example. Temperatures today will be above 32 degrees, but not as high as 40 degrees. That's got a low boundary. There's your low. And you've got an upper boundary. There's your upper boundary. And you can see it's an inequality. Are they included? Well, it says it's above. So to me, if I interpret that, and I'm hopefully interpreted correctly, it's going to be greater than that value, right? 30 is going to be the larger of that. And then 40, it says not as high, so all our values have to be behind it. So it's not included. It can't be 40. It says not as high as 40. So we need to figure out a variable here so that we can call this. We'll probably use T for temperatures. So we're going to put T in the middle. We know it's got a low boundary. It's not included. And we know we have a high boundary. You can start your compound inequalities just like this. Identify your variable or whatever's in the middle, and you can start with two less than signs. That is the standard way. And you've seen that before with our interval notation, so at least it's consistent there. So if this is kind of an interval, which we've done before, so 32 is our low and 40 is our high. Yeah, that looks just like a domain or a range or any interval that we've identified so far. That's what this is. That's what a compound inequality is good for, is identifying intervals. Here's another example. You can pause and take a look at that if you need to. But let's go down here. How do we solve a compound inequality? We've done the notes in 3-4 that showed us how to solve one inequality, but now we've got two inequality signs. So how do we do that? Well, to do it, we're going to do two techniques. The first one we're going to do is we're going to solve them separately, just so you can see that it's done. So if I look at this, I'm going to take the left half of the inequality, so the center with the variable, whatever is in the middle of it, and I'm going to separate that off. So I'm going to get negative 6 is less than or equal to 3x, and I'm going to solve this just like it's a separate inequality. On the right side, I'm going to do the same thing. I'm going to take that 3x again, but this time I'm going to use the upper boundary, which is less than 15. I'm going to solve these separately. Watch what happens. Divide by 3. So I get negative 2 is less than or equal to my x, right? So here's my low boundary, negative 2. And all the values of that, right, or x, the solutions, it's on the right, so we got to say the solutions, we run into the open side, are greater than negative 2. So I'm going to start here, and I'm going to graph this way. So I'm going to go over and solve my other side. So I'm going to divide by 3 on both sides. So x is less than 5, oops, not 15, but 5. And so I'm going to go to 5, that's my boundary point. It's not included, so it's an open circle. And it says my solutions are, I run into the point first, less than 5. So I'm going to graph this way. So really, all the solutions are going to run to each other, and we get that bar that we know is common with an and type of inequality. Okay, so this is a compound and inequality. And again, here's another example if you want to take a look at that. I'm going to pause the video here and call that part 1, and then I'll make a part 2 that you can watch, and I'll see you then for that one.